Hello and welcome to another lesson in math. And today we are going to talk about sets and their operations. We will talk about important ideas of the lesson. Let's get started. Let me just pick up that marker and we're ready to go. So we got some important things we should get. The first thing first, integers. Integers begin from zero. Zero is the king of them. And if you go to the left, you will see negative numbers. 1, -1, -2, -3, and so on. After that, we got positive numbers like 1, 2, 3, and so on. We got another thing called natural numbers. Their symbol is N. Symbol is N, and they're called natural. They begin from zero. They should contain zero. After that, we complete 1, 2, 3, 4, and so on. This means that it's an infinite list, infinite set. Last but not least, rational. It's Q, and it begins from zero, the same as integers. But now we got negative and positive. So rational is just a team up of integer and natural. They teamed up and made rational, but they got fractions and decimals. Like what? Uh, 1 is rational. -2 is rational. -1.5 is rational. -1/2 is rational. 1/2 is rational, and so on. Yeah, basically, don't forget this. Don't forget counting numbers. They do not contain zero. Means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. After that, one of you will say that the set contains these brackets, and yep, this is wrong. Other one says that we'll use this, but it's wrong. But one of you will say we'll use braces, and yes, this is correct. This type of bracket is called braces. This is called brackets, and they're used only in operations, order of operations, and that's not our topic. And this talks about list, and that's not our topic either. But this is our topic, the sets. Now, do you want to know how to do it? I'll show you. Just S and then reverse S. Reverse S and an S. So S, reverse S. Reverse S and an S. That's how you do it. So we got the symbol. So I know most of you will freak out and say we don't know these. What are these? Okay, let me. So this called belongs to. This does not belong to. This subset of, not subset of, and phi. And the phi is always empty. Like it's not zero. It's not zero zero. If you put zero inside, it won't be empty, so it's not equal. So the phi does not equal to zero in the bracket. Now let's begin our lesson. We got here the concept of a set. A set is a collection of well-defined objects. What's the meaning of well-defined? Well-defined means that they are known. Everyone knows it. Does not contain options. Opinions doesn't vary from person to other. This means that does not contain opinions. Like um, if I said here, beautiful flowers. I made a set of this, like rose and this type of stuff. Other one will say another types of flowers. So this should be not a set. It should be something defined. Everyone knows, like integer numbers. Everyone knows that the -1 is an integer. 4 is an integer. 0 is for the integers. 4 is an integer. -6 is an integer. So it will be, yes, it will be a set, but the other one will be not a set. Now, expressing a set. Listing method. To express a set using the listing method, write all elements between braces. You shouldn't type brackets. You should not type lists. It should be normal S, reverse S, reverse S, normal S. Like what? We got A equals, we got here a variable can be potato, it can be tomato, anything, equals, and we open these braces. 3, 4, 5, any number you want, anything. You can type here address, got here, address, got ADDRES. Someone of you will say you'll type ADDRES, and it's wrong. Why? Because we should not repeat the element two times. It should be one time. Like type ADRES only. The second thing we got is set builder method, and I will not explain it in this video because it might be too long. We got the third one, Venn diagram. Yes, this Venn is just like some sort of like circle, triangle, square, anything, but let's just stick to the circle one because it's a bit easier. And you should begin with an X beside a number, and you should order them. Like you can order them in any order. Order does not matter, even though here in the listing method, order does not matter. We got here in the Venn diagram, order does not matter. Okay, next. Should remember that integers, 0 is the king. From the left, negative numbers and so on. From the right, positive numbers and so on. Natural begins with 0 and so on. Positive numbers and so on. Rational begins from 0, negative numbers and so on, positive numbers and so on, in addition of fractions and decimals. We got here, don't forget counting numbers does not begin with 0, no 0 here, and you just continue with positive numbers. We got here 1 belongs to 2, 1, 3, 4. This belongs to means it's in the set. 5 doesn't belong to 2, 1, 3, 4 means that it does not belong. As you can see, there's no 5 in the set, right? Yeah. We got 1, 2, subset of 2, 1, 3, 4. You tell me, teacher, it's not here. Like 1, 2 is not the same as 2, 1. No, order does not matter. We know order does not matter. Should be the same numbers at least. 1, 5 does not subset of 2, 1, 3, 4. No, 1 is the same here. No, it should not be like this because 5 does not belong. 5 is not here. So, yeah, it's not subset of. Notes the empty set. Yeah, this is called a phi. Don't forget it. But a phi. And a phi equals S and reverse S and S, and don't tell me 0, it will be not equal. Anyways, the empty set phi is a subset of any set. For example, phi subset of ABC, phi subset of 1, 2, phi subset of integers, phi subset of rational, phi subset of anything. Any set is a subset of itself. For example, x subset of x itself. 1, 2, subset of 2, 1. But you said no, they are not the same order. Order does not matter, right? Yes. Yeah. We need to list all subsets. The subset first thing first should begin by taking each number out and putting it in its own list. 207. Yes, we made it. Did you finish? Yes. Now what's next? You should take two numbers each time. I got here 20 and okay 07. Okay, got 27. Okay, now we have finished. Should be random. Okay, did you finish? Yes, I finished. Now we got the third thing. We should type the whole set same here. Now the last but not least, the phi. Phi is subset of any list. Make sure this belongs here, or else you will lose a mark in the exam. But what if the number of elements in the set is a lot, like a lot. They a lot. What should I do? Make sure you just like count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and just to the power of 13, and you just calculate it. You calculate it because it's a big number, so you know it. Anyways, get the next. Sets and their operations. Every element set A belongs to set B, and every element of set B belongs to set A. Therefore, A equals B. Is that here A equals 5, 2, 4, and B equals 2, 4, 5, and then A equals B. But be careful. You tell me, hey, they're not the same order. Order does not matter. We said order does not matter. Order does not matter. Order does not matter. It should be the same. It should be the same numbers. Same number. Yeah. 2, there is 2. 4, there is 4. And they will not be equal if there is another number like 5. No, shouldn't like 9 should be not equal. We got here need x and y. So first thing first, you should look the 3 is here. So leave it. 4 does not it's not here. So x equals 4. Simple and easy. Second one, 3x 5 I right. 5 is in this, right? But it's not here. So x equals 5. Okay, okay. 3 is here, but 3 is not here. So y equals 3. Okay, I'm starting to get it. Yes? Okay. I'm starting to get it. 2, 3, y minus 5 equals 7, 3, x plus 1. Oh, what the heck? What's this? What's this? Okay, let me explain. So, so we got here, the 3 is here, so make sure you cancel it. Do not look at it. We got here, 2 is, 7 is here, but it's not here. This means y equals 7, but it's wrong. Why? It says in minus 5, so it makes 7 plus 5, and just get the answer. Same. With 12. Same. 2 is not here. But it says here x plus 1. You say 2 minus 1 equal 1. So x equals 1. We're about to finish, guys. We got here union and intersect. What's union? Union means to make all the sets to interact together to form a one unit set. But please don't repeat the number again. It's illegal in this. But if you want to see what's the same between them, you just like get the union, let it stand on its head, and just get the intersects. So yes, union, let it stand on its head and it will be intersect. So intersect means to get the same numbers to like I got 2, 1, 2, and we got the second one 2. Yeah, we need to know what's the same between them. So it will be 2. Important notes. This will get in your exam, and this important. So for any two sets A and B, if A subset of B, then A intersect B equals A and A union B equals B. If A union phi equals A and A intersect phi equals phi. If A equals B, then A union B equals A or B, and A intersect B equals A or B. If A and B are two non-empty sets and A intersect B equals phi, then the two sets A and B are joined non-intersecting. Thank you guys. Thank you guys so much, and see you in the next video if I can. Bye.